Dear students, in the last two classes, we discussed how the equation of a line in space can be obtained, and we have obtained two equations, that is equation of a line passing through a point A, x1, y1, z1 and parallel to a vector B. We obtained equation of such line passing through a given point and parallel to a given vector, and that was this: vector r is equal to vector a plus lambda vector b. Now looking at this example, there is one equation given. Vector r is equal to 2i cap plus 3j cap minus 4k cap plus lambda into this. So whenever you will find this equation, immediately you could able to tell this is an equation of a line passing through a point and parallel to a vector. Now you must able to tell what are the direction ratios of this line and what is the position vector of one point that lies on the given line. Okay, so from this equation, if any equation is given like this, its direction ratios must be written immediately. Its direction ratios are you can write ABC. These are the direction ratios, coefficients of I cap, j cap, k cap in this part. Okay, because this is equal to this vector B. Here 3, minus 2 and 1 stands for direction ratios of this given line. Okay, so for any given line you must immediately tell what are its direction ratios when it is given in the vector equation form. This vector stands for it is position vector of a point that passes through this line. Suppose a line is passing through this point A, then its position vector is nothing but vector A, and that is nothing but this vector, that is your 2i cap plus 3j cap plus. So what is direction of this means? The direction of this is this vector, and that is nothing but this vector 3i minus 2j plus k cap, you can write. So for any given line in a vector form, you must able to tell what is its direction or what are its direction cosines. So this stands for the direction of this line vector r. So I will be giving one more example and you must tell me what are its direction ratios. So let us see here. So if this is the line, vector r is equal to 3i minus j plus 4k cap is understood, you can write, plus something mu into 3i minus 2j minus 4k cap. Then what are its direction ratios? Okay, so what are its direction ratios means the coefficients of I cap, j cap, k cap in this part, that is the ABC are the direction ratios denoted, and they are 3, minus 2, minus 4. So in this way you must identify what are direction ratios of a given line. Also in Cartesian form, Suppose if you are given x minus x1 by a, as we all derived it, y minus y1 by b, z minus z1 by c. Even if you are given equation in terms of Cartesian form, this, you must tell me what are its direction ratios. These denominator stands for direction ratios of a given line, and this x1, y1, z1 stands for a point on the line. So geometrically this is nothing but it is this line which passes through a point x1, y1, z1 and has the direction ratios a, b, c. Okay, so it is parallel to some line here, some vector you can say, and direction ratios of this line are nothing but direction ratios of this. So direction ratios of this line are a, b, c. So from given Cartesian form, you must tell what are its direction ratios. Okay. Now in order to identify direction ratios, you must confirm that the given equation is in the form x minus x1, y minus y1, z minus z1. Means coefficients of x, y, z must be 1 always in order to decide direction ratios. So let me tell you one example and you have to identify what are the direction ratios. For example, if I give you this x minus 2 by 3, y minus 1 by 5, z plus 3 by 6. Then what are direction ratios? What are its direction ratios? Now look at what are the coefficients of x, y, z? There are absolutely 1 here. Now you can confirm that whether this is in this form. Compare this with this. We have x minus 2 by 3, y minus 1 by 5 and z plus 3 by 6. So this plus 3 can be written as minus of minus 3. Okay. So now it takes the form x minus x1 by 3, y minus y1 by 5, z minus 3 by 6. That is x minus x1 by a, y minus y1 by b, z minus z1 by 6. So here, if you compare this with this, you will find a point on the line is what? 2, 1, minus 3. So this is the point on this line. So from given Cartesian form, Cartesian equation of a line, you must tell what is the point on the line. And what are direction ratios? It's a direction ratios. You can set in short, you can write DRs. So direction ratios are the denominators 3, 5, 6. So these are the direction ratios. So let me tell you one more example. So here is a line and you are asked to find what are its direction ratios. So this is not in the standard form. Looking at this, we want in the form x minus x1, y minus y1, z minus z1. Let me write here, this is your standard form x minus x1 by a, y minus y1 by b, z minus z1 by c. So you have to express this in this form first. Okay. So divide numerator and denominator by 2 here. In this case, In this case, you have to divide by both numerator and denominator by 3. In this case, you have to divide both numerator and denominator by 4. Okay, to both numerator and denominator. To both numerator and denominator. Okay. Now, if we divide it by 2, what will get? X. If we divide it by 3, you will get 3 by 2. If we divide it by 2, you will get 5 by 2. Here, if we divide it by 3, y. If we divide it by 3, 2 by 3 divided by 7 by 3. Similarly, divide to make the coefficient of z as 1 divided by 4. So 4 cancels. 6 by 4 you will get divided by 8 by 4. So looking at this, now you can confirm this is in the form of this. Okay, so this plus can be written as minus of minus 3 by 2. So I will show you again it. So this can be written as x minus of minus 3 by 2. Few students can write directly. If there is a problem with every student, so I am keeping them in mind. So I am doing it in detail. Okay. So because everything is based on direction ratios of line. So this can be written as minus of minus. If you want, you can simplify this. This is 3 by 2. 2 3s are 2 4s are. This you may write it as 2. So from this you can write direction ratios. So direction ratios are 5 by 2, 7 by 3 and 2. Whereas a point on the line is minus 3 by 2, 2 by 3, minus 3 by 2. So I will write here. So direction ratios are 5 by 2, 7 by 3, 2. And point on the line, that is x1, y1, z1. Point on the line is, you can write minus 3 by 2, minus 2 by 3 and minus 3 by 2. So this plays very important role in understanding concepts of or problems of three-dimensional geometry. So looks to be very simple or very silly. If you don't know these things, if you make little mistake, then you will hang in the solving problems. Okay, so this is one of the important thing to be noted. Students, here is an example. Show that the lines this and this are perpendicular to each other. So as we know that, when do you say that two lines are perpendicular? So we know that if A1 A2 B1 B2 plus C1 C2 equal to 0, then what will happen? Two lines L1 and L2 are perpendicular, that we studied in condition of perpendicularity. So here A1 B1 C1 and A2 B2 C2 stands for direction ratios of two lines. So if we know the direction ratios here, then verify this result. So let's understand. So please make your notes while learning or watching the video. Pause the video, go on making your own notes. That will take you long way. just simply watching you cannot understand, or you will forget the things very easily. So in mathematics it is very essential to have a pen and paper while watching any kind of video of mathematics. So let's see here. So here, okay, looking at this, they are in the standard form or not. Means x minus x1 by a, means coefficient of x, y, z you first see. If they are 1, 1, 1, then you can write immediately its direction ratios. So here, what are DRs of? I can call it as L1 and this has line L2. Okay. So DRs of L1, I can denote them by A1, B1, C1. Okay. Clearly, coefficients of x, y, z are 1, so immediately denominators are the direction ratios. So it is 7 minus 5, 1. And direction ratios of second line, I can call them as A2, B2, C2. Okay. Here also coefficients of x, y, z are 1. So immediately these are the direction ratios. 1, 2, 3. Now our aim is to show that they are perpendicular. So consider this product, sum of the product. So consider A1 A2 plus B1 B2 plus C1 C2. Substitute here 7 into 1. Either you can write directly or those who are average, they can do it step by step and later on you can do of your own. 7, this plus into minus minus, 5 2s are 10, 1 into 3 is 3, so clearly it is 7 plus 3, 10 minus 10, absolutely it is 0. So this is 0. So what is your conclusion? So this implies you can write given two lines are perpendicular. Okay, so in this way you have to use the condition of perpendicularity to check whether two lines are perpendicular or not. Here is one more example. Show that the lines this and this are perpendicular. So identify the direction ratios. So here DRs of L1, I can call this line as L1 and this as L2. So direction ratios of L1 are, you can call them as A1, B1, C1, which are 4, 1, minus 5. And direction ratios of L2, A2, B2, C2. Okay, 5, minus 5, 3. I have written directly because look at the coefficients of x, y, z, they are 1, 1, 1. So directly you can write A1, B1, C1, A2, B2, C2. So now you have to consider the product. Sum of the product you can write A1, B1, C1, that is, sorry, A1, B1 plus A2, B2 plus now consider the sum of these two A1, A2 plus B1, B2 okay. Now consider the sum of the products A1, A2 B1, B2 C1, C2. Okay. So let us multiply directly. 4 into 5, 20, 1 into minus 5 into 3, minus 15. So it is 20 minus 20, which is 0. So directly you can conclude that now given two lines are perpendicular. Now see here one more example. If the two lines, you are given two lines are perpendicular, then find the value of P. Means for what value of P these given two lines are perpendiculars. So let us try to understand or first find what are direction ratios of given two lines. First confirm that whether they are in the standard form, means coefficient of x, y, z must be 1, 1, 1. So look at this, 1, 1, 1 we have, no problem with this. 1, 1, 1, no problem with this. Okay. Now we can write directly direction ratios of L1. Okay, I can call it as L1 and this is L2. So A1, B1, C1. 3, 2, 4. Similarly, direction ratios of L2. A2, B2, C2. Okay. So it is 4P3. Now what it is asked is if they are perpendicular, then what is P? Okay. So start like this. If L1 perpendicular to L2, then what will happen? Then A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Okay. So substitute here A1 A2, that is 3 into 4. Either you can write directly. Those who can't understand, they just follow me and later on you can write. I hope you do it directly. 4 into 3 is equal to 0. Okay, substituting the values of A1, B1, C1, A2, B2, C2. Simplify this. 12, 2 into P, 2P, 4 into 3, 12 equals 0. This implies 2P, 12 plus 12, 24 equals to 0. So 2P equals minus 24, P equals minus 24 by 2 and P is equal to minus 12. So in this way you could be asked to finding some value of unknown by using the condition of perpendicularity. Students, we will have one more example of same kind but little bit variations. Now see here, find the values of P so that the lines this and this are at right angles. Right angle means perpendicular. Okay. So same thing, if two lines are perpendicular, then what are the values of P? First you need to identify what are the direction ratios of these two lines. If you identify correctly, half of our work is finished. Now see here, what are the coefficients of x, y, z? Are they 1? See here, coefficient of x is minus 1 here. Coefficient of y is 7. Coefficient of z 1. No problem with this. Look here, coefficient of x is minus 7. Here it is 1 5. Here it is, coefficient of z is minus 1. So you need to do something with the direction ratios to find. Okay. So first we will express them in the standard form. So better you write down the question, and if possible please pause the video and do it of your own, then you can verify your result. That takes you long way, that makes you brilliant, that makes you top in the class. Okay, so just start doing yourself. Okay, so first express this in this standard form. Brilliants can do of their own within a short of time, and for few students it takes time, but one or other day you will become brilliant. So let's understand. I am doing it in detail, so those who understand, they just forward the video. Okay, so here 7y minus 14 by 2p z minus 3 by 2. My first step is bringing all x, y, z as a first term. Okay. Next, try to make the coefficients of x, y, z as 1. So here coefficient of x is minus 1. So divide numerator and denominator by minus 1. So divide by minus 1 to both numerator and denominator. Okay. So divide both numerator and denominator. I will write here. Divide both numerator and denominator by, okay, in respective term. In this term by minus 1, in this term by 7, in this term nothing, because coefficient of z is 1 out there. So what you will get? X 1 divided by minus 1, that gives you minus 1. 3 divided by minus 1, you can write directly minus 3, or you can write in this fashion. Okay. So dividing this by 7, so you will get y. 14 by 7 gives you 2, and you may write 2p by 7. Here coefficient of z is 1, so you keep as it is. Okay, now you can tell what are the direction ratios. So these are the direction ratios. This is your A1, this is your B1, this is your C1. Okay, so A1, B1, C1. Similarly, write this in the standard form. Okay, so this can be written. Better write down this and start doing. First step is I can write it as minus 7x plus 7. Just changing the order. I am not doing anything extra. Y minus 5 by 1. I can write just minus z first and 6 next plus 6. Okay. Okay. Now try to make the coefficients of x, y, z as 1. So here also you can do the same thing. Divide both numerator and denominator by the respective coefficient. So in order to make the coefficient of x as 1, divide it by minus 7. So that should be divided to both numerator and denominator. So dividing both numerator and denominator, this by minus 7, and in this case nothing is required, means 1. So here divide both numerator and denominator by minus 1, because the coefficient of z is minus 1. Okay. So if we divide it by minus 7, so minus 7 by 7 is minus 7 by minus 7 is 1. So you will get with x. 7 by minus 7, 7 7 get cancelled, you left with minus 1 divided by 3p by minus 7. here as it is. In this case, okay, so dividing by minus 1 means you will get z. 6 divided by minus 1, that you get minus 6. So you will come up with this. Now, you are asked if the two lines are perpendicular, then what is P? So, let's use the condition of perpendicularity. So, if L1 and L2 are perpendicular, then what is true? A1 A2 plus B1 B2 plus C1 C2 equals to 0. So simply substitute the values of A1 B1 C1, A2 B2 C2. So these are the direction ratios of second line A2 B2 C2, these denominators. Okay, so use them. So 3 by minus 1, either you can write minus 3, and A2 is this 3p by minus 7. Okay, B1 is this 2p by 7, B2 is 1, C1 is 2 here, C2 is, we can write minus 5. 5 by minus 1 is minus 5. Okay. Now, rest of the thing is simplification. Some students are very fast. They can do very quickly. Minus minus cancels. And 9p by 7 plus 2p by 7 minus 10 equals to 0. This implies, okay, 7 is the LCM, 9p plus 2p, okay, 7 tens are 70 by 7 equals to 0. This implies 9p plus 2p, that is 11p minus 70 equals to 0, because transferring 7 this side, 7 into 0 is 0. So 11p equals to 70. So p is equal to 70 by 11. So this is the value of p for given conditions. So in this way, you learn how to find the value of some unknown. It could be k, it could be lambda, it could be p. So just understand the condition of perpendicularity.